Okay, so data science. Okay. So what basically data science is combination of two words, right? Data and science. So whenever we try to experiment with data or do some R&D or some analysis. Okay, so we have data, and whenever we do any kind of experiment, what is science? Science is basically experiment, testing, analysis on any specific things. So when we try to do any experiment analysis and try to get inference from the data, then we generate to data science concept. Now basically let's say I have one series of data 2, 4, 8, 16. Now if we try to predict what will be the next data, okay, so we can easily predict the next data by seeing the pattern over here. So 2 into 2 4, 4 into 8, 8 into 16, and next will be 16 into 32. Okay, so what we did is in this data we do some analysis and we try to do some experiment, or we try to find some pattern over this series of data and try to accept. So we try to experiment on this data and try to find the what will be a next data. Okay, now people are coming. Okay, let's wait for 2-3 minutes if they are coming right now.
Who is coming?
People are joining so late, so just wait for 2 minutes again. Okay, 2 minutes more.
Okay.
Maybe some more people will show you.
Karan, can you quickly review what you have told in the last 10 minutes?
Just wait for 2-3 minutes more because now people are joining right so late.
Okay,
So we're
okay,
waiting
fine.
just a few minutes more.
All right.
Mm. Okay, so people who don't know me right now, so many people I can see, new people who are joined right now. So let me introduce myself first, and then we'll wait for 2 minutes and start our session today. Okay, so basically my name is Karan Shrestha, and I am currently master's student in San Francisco Bay University, and I have experience of 4.5 year of 4.5 year of experience, yeah, approximately. Actually, I was working as a full stack developer and also worked as a data scientist. So and I have data scientist certification over here. So it was like 1 year data science master certificate. I started from 2019 to 2020. Okay, so I have other different machine learning certificates and training also, and data science as well. And this is my experience journey. Yeah, that's pretty much about me. and I have worked in technology wise. Basically, I worked in .NET, web APIs, web development, and AI, Python, MLDL, and as a senior data scientist is my last position. So yeah, that's about myself and about the course. So today we're gonna complete these 2 points. So introduction to data science, AI, and machine learning, and then after we will discuss about the data science lifecycle, which is very much important, and we'll do some installation of Anaconda. I will let you know about that. So I think let's start with our session today. I think that's it for today. Okay. So basically I was talking about data science. So the word data science, how does that started basically? Okay. So data science consists of 2 words. One is data, one is science. Simple, right? Yeah. So what is data? Data is anything which we have a raw or meaningful or not meaningful, something like that. Data. We don't need explanation what is data. Okay. So what is science? Science is basically experiment, R&D, analysis. Whenever we talk about science, there is experiment, right? So when there is some data and when we do experiment, some research or some analysis or some inference from that data itself, then we come to the concept of data science. So I was explaining with one example. So let's say, for example, I have one data, this 2, 4, 8, 16. If I say what is the next data, so we can easily predict it is 32. Why? Because 2 into 2, 4, 4 into 8, 8 into 16. So how did we know about this? We tried to do some analysis over here. We did analysis that after 2, it's every time it's multiplication 2. We did some experiment, we did some analysis. I am explaining in a very simpler way, okay, in very basic low level of things. So in this way, we try to find what is the next number. So this is also data science. Okay. Whenever in any data we find any inference or any analysis experiment, that is data science. Okay. Now data science has come to machine learning, deep learning, okay, and AI. Now when we do data science, okay, now the difference you will see what's happening in this. Data science is study of data, experiment data, right? When we do something when we play with some data, we come to AI. Okay. So what is AI basically? So let's start with this. So AI is basically mimicking human intelligence. Okay. So when we try to mimic as a human, so how human thinks, something like that, that is AI. And how do we make machine to think like human using data science concept? Okay. And hmm, now AI has 2 parts: machine learning, deep learning. Okay. Now AI is mimicking human intelligence. Okay. Basically, it's a concept. We call it the concept of mimicking human intelligence, or we can say it is a technology which mimic human intelligence in very basic level. Now, how will achieve this AI, the mimicking the human intelligence, using machine learning, using deep learning. Okay. So if I try to picturize in diagram, so DS will come in this. Okay. And within this DS, data science, there is AI, And within this AI, we have ML and DL. Or we can do one more thing. We can put this DL into this ML in this subsection of DL also. That's it's basically we can do in both way. We can separate DL or ML in different way. Now I will try to explain what is ML versus DL. So machine learning, okay. So both are mimicking human intelligence, that is we call AI, okay. Both work as a mimicking human intelligence by some algorithms, okay. So machine learning and deep learning, whenever there is a data in a tabular form, okay, whenever the data in a tabular form, let's say example, I have a data to predict the house price, okay. This is price and I have different and I have different features like number of bedrooms, okay, number of balcony, okay, or what we say, or back area and age, how many years that house is being built up, okay. So whenever there are tabular data and we try to do some algorithm over it and try to get a prediction. So basically we have already a set of data, tabular data, okay, or numerical data, and then we try to predict. At that time we always use machine learning. We don't need deep learning, or we not use deep learning, okay. So the first thing is we'll explain this machine learning in further classes, okay. But right now, just to differentiate the machine learning versus deep learning, just keep in mind that whenever there is a tabular data, okay, tabular data, and we try to use some algorithm and try to mimic as a human intelligence, then and get some prediction, then it's called machine learning. Then what is the difference between DL, that is deep learning? Okay, so what is deep learning? Now, let's say example, I have one image of cat and one image of dog. So can I make this image like in tabular form, tabular data by myself? Can I make this dog as in tabular data to feed in machine learning algorithm? No, right? I can't. I can't create directly the image into tabular data because machine learning requires the tabular data to train our model. But if we work on images, let's say example, to differentiate between cat image or dog image, or example, face recognition. So many attendance has like feature to face and attendance face recognition using face, okay. So when the face is detected, this person is A, this person is B, something like that. Whenever there is image and we try to do prediction over there, then we cannot use machine learning, okay. For that we need tabular data and we cannot convert directly image into tabular data by our own self, okay. By so we need deep learning, that is called neural network. And neural network is just as a human, and neural network is just like a human brain, okay. Neural network just like a human brain. We don't need any tabular data for deep learning. We directly give cat and dog image to our deep learning model, and it will train over it, and it will predict whether it's a cat or dog, okay. We will give a label, basically we will give our table label, this image is cat, this image is dog, right. And the deep learning itself handle the images, okay. So the major difference between ML and DL is whenever we have a tabular data or any kind of numerical data, okay, or some Excel sheets or whatever we can say, okay, then we will use ML, machine learning. And whenever there is a images or some raw data which we cannot convert directly into the table, okay, then we use deep learning, okay. And at at last, these what these two are doing, these two are doing for AI concept, okay. So there is no confusion between what is AI. AI is a concept. AI is a concept or technology we try to achieve using machine learning or deep learning. And what is data science? Data science is the top of the everything, because if there is no data, if there is no science, we cannot do anything analysis, we cannot do any equation, then we cannot achieve AI. So data science acquire both machine learning, deep learning, okay, to achieve AI. So data science is the upper level concept of it. Okay, now I will show you the, it's already it's visible. So do I have to zoom? Okay. So theoretical wise, data science combines maths, statistics, okay, special programming, analytics, as I have said already, analytics, AI, and machine learning, okay, to uncover actionable insights from the data. Okay, so there is data, and using these all things, analytics, machine learning, we try to get some insight from the data, and that data is used to decision making. That insights is used to decision making and strategy planning. So many companies use their decision making and strategy planning using data science. Okay, and now AI, that is a technology, okay, that enables computer and machine to simulate human intelligence. Simple, nothing more about the AI. And to achieve this AI, there is machine learning. Okay, so it is a branch of AI. See, that focus on using data and algorithm to enable AI. Okay, it will enable the AI. Okay, that imitate the way that human learns. And similarly, deep learning, it is a subset of machine learning. Okay, so I have said that in the diagram, in this diagram. So we can put this DL into machine learning itself also. So we can say machine learning is a subset of DL is a subset of machine learning. Okay, so it works on neural network. We call deep neural networks. Okay, and it is used to simulate complex decision power making of the human brain. Okay, so images are more complex than tabular data, right? So that's why we use deep learning. Okay, so I think it's pretty much clear. So if there are anything doubts, you can ask me right now. So data science, and then machine learning, and then deep learning, and in the middle of this there is AI. Okay, so is this clear, or I have to explain something more? You can confirm on the chat if you and have any doubt or clear. Okay, so here is the diagram: AI, machine learning, deep learning. So the diagram is like data science is in every circle over here. Okay, or you can put this data science circle in top of this AI, ML, DL. Both way works. Okay, either put in the common circle or on the top of the tab. Okay, now let's come on the data science life cycle. Okay, So basically, whenever a company or any company work on machine learning project or data science project, so how does they work? How they start? So that's the basic idea for data science lifecycle. Just like we have project management, right? So for there is an agile cycle, we say requirement and then development, testing phase, something like that. Similarly, the data science has its different life cycle, its individual life cycle. Okay, so let's say company. Okay, so let's say company ABC is the, let's say, AI company, and there is some client A. Okay, this client has particular problem X, let's say, and the problem has to be solved using, let's say, machine learning or data science thing. Okay, now this client approach to this company. Okay, now this company will see what's the problem. They will discuss with their clients what the business problem and what they have to achieve. Okay, so very first thing is business problem to understand. Okay, so let's say, for example, same example, let's say the client has to create one model which will predict house prices. Okay, so let's say they have a problem to create a model that will predict house prices. So the first question will be, the company will ask, okay, on what basis they will predict. Okay, so they will decide to create a data. Okay, see, if I tell you I have to predict house price, let's say I am in right now in the Fremont. Okay, so I need to purchase one house. So if I say I need to purchase house, then first question you will ask, what is the place? Okay, it is a 2 bedroom or 3 bedroom. Okay, and what is the location? There is x n number of you say feature you will ask, right? So what kind of things you want? On that basis only you will say, okay, for this area, for 2 bedroom kitchen, and there will be like um 10,000 or something, any x price there will be. Let's say example, I'm just taking example. Okay, so based on some feature you will try to predict the house. In general case, when we talk with people, right, what we do, we'll ask how many bedroom you want, or how many balcony you want, something like that, right? So there is some feature that we call feature. Okay, so the company X will ask the client what feature or what data they have. So that part come under the data collection part. Okay, so the company will ask what data you do have. So do you have historical data or something like that? So that part come under the data collection. Once the business problem is clear, that we have to predict this one price. Okay, now how? Now we come to the data collection part. We need data, because without data you cannot predict. If I tell you to predict the house price in this area, then how will you predict? You will predict based on the history, right? Last year it was, the price was something like this for 2 bedroom kitchen. Okay, and previous year, so last year was, there is a $20,000. Okay, so now maybe it will be $35,000 maybe. So you predict in based of the historical data. Similarly, we need data for that. So machine learning also need data for that. Okay, so that part is comes under the data collection. Now the data is collected. Okay, now what? Now we need to come in the data cleaning and data preparation part. Okay, which is very much important. The data can be dirty, right? Data can be many columns can be null. Okay, so for example, I have data over here. Maybe some rows are null here null, because and some rows are different data. Let's say for integer data type there is string data type. Okay, so we have to clean whole of data, and we need to prepare for our next step. Okay, so without clean data we cannot process further. So this step is very much simple. We need to clean data. Okay, we need to remove all the null values or replace with some other values. Simple. Okay, so once the data is clean and ready, then what we do? We do we call basically EDA. So in data scientist job, we call this EDA very frequently. So without EDA, we cannot go any further. Why EDA is important? Now let's say exploratory data analysis. So what these steps do is like we try to get some insights from the data. Okay, so let's say I have this data. Okay, so let's say based on area, so this is feature area, this is feature bedroom, this is feature balcony, this is feature area. Sorry, age. Age means the how many years that is already built up. Okay, so number of years it has been already in this area. So something like that. So if the area is 1200, any let's say unit square foot, anything you can keep just for example, and number of bedroom is 2, and there is no balcony, and it is been of 2-year old. Oh, then the price is okay. Then price is $500,000. Okay, 500K. And similarly, we have different data over here. Now, based on that, I have to train my model, my machine learning model, based on this data. And whenever there is some new area, new bedroom, new balcony, and let's say for 5 years, what will the price? Let's example. We have to predict in this way. Okay, this is the historical data. Now, what do we do with EDA? So from this data itself, can you tell me which feature is more important? Okay, so you will say bedroom seems to be more important. Why? Because if there is 5 bedroom, the price is very high. So and if there is 1 bedroom, then price is very low. Okay, so what we are doing over here, we are getting some insights. We are getting some insights. We are getting some inferences. We are getting inferences. Okay, we are doing analysis based on data. So this EDA part is very much important. The company will try to do EDA part, try to do exploratory data analysis over here, and try to find what insights this data is giving. It's giving that more is the bedroom, more is the area, more is the price. And now you will say it's very clear that number of bedroom, if there is high, then that the price will be high, because this is a small data set, right? I am taking just for example. There in real life, in real industry, this feature will be go up to 100 times also. Now we have 1 2 3 4 5, 1 2 3 4 5 feature, right? If I will show you I will show you later. The feature will go up to 100, 200 also, 500 also, right? So if there is 200, 100, 500 columns, okay, so can you uh, analyze, or can you give insights by just seeing the data only? Right? No. Okay, no, you can't. So that's why we do some coding in the EDA part and try to give some insights. So that part came from the stats. We do many stats part like normal distribution, something like that. Okay, standard deviation, mean, something like that, right? And we try to find some insights. And once the insights or inference we get from this data, we present into data visualization, something tables or charts or dashboard we create, and we present to our client to show that these are the inference from your data we are getting. Okay, so do you agree with this or not? Do you have something like pattern or not? We will showcase with insight. So EDA part is pretty much important. Okay, so what is EDA part? Just understand these 3 words: insights, inferences, analysis. Get some insights, get some inferences, get some analysis. Okay, from this data. Okay, now after that, once the EDA part is done, we go to feature engineering. Now, what is feature engineering? So as I have told already, these columns are feature, right? These are feature. Okay, so based on area, bedroom, balcony, age, we predict price. So this area, bedroom, balcony, age comes under the feature. Now what is engineering? When we try to do some engineering in this. So what is engineering over here in feature engineering? Let me explain you now. Okay, let's example, I have one more feature over here. Okay, one more feature, let's say color, for example. So the color of the house, the color of the house is, let's say, pink or orange or black or XYZ, let's say. So can I say that this feature is not so important to predict the price? It may be, but not so important, right? Because color is not so impactful to predict the price. Area, yeah, definitely. Bedroom, definitely, right? So area and bedroom is very much important to predict the price. But can I say that color is less important? Or we can say if I remove this color column from the data, there will be no impact. But we don't remove directly from the data. We do some test. It's like hit trial and error, something like that. We remove this and try to test with this what is the accuracy, something like that happened. I will explain in the future. But for right now, we can say that if I don't give this color to my model, okay, now will you know impactful? So I can remove. Why to give this color? Now why I'm saying this, let's come to again. So let's say I have 100, 200, 500 of feature. It's in real life there will be this much of feature many times. So let's say if from 100 to 200, we when we implement feature engineering and we found that out of this 100, 40 feature are not so important to give our machine learning model, to our machine learning model. Okay, so what you can do, you can remove this 40 feature over there. Now it will come to 60. Okay, 60 important feature. Now why we should remove 40? That's because when we give 100 feature and 40 is not so important, right? So why it is necessary, unnecessary feature we should give to model, our machine learning model, to make more complex model? Because if you give hundreds of 100 or 200 of number of feature, then our machine learning model will get more complex. It will get more time to predict, right? So we try to minimize as much as the feature, the only important one, which is directly giving impact to our prediction column. If there is some feature which are not so important, how we're gonna do that, we'll see in the coding part. Okay, but for now just understand that we try to remove some feature which are not so important to prediction. Okay, that is called feature engineering. We try to experiment with all the features and see which are more important to our prediction or not. Okay, so that's come under the feature engineering. Now the important part, last final, the machine learning model part. Once the feature engineering done, we'll remove unnecessary column. The important columns we have retrieve the important feature over here. Okay, this is prediction. This is feature 1, feature 2, feature 3, feature 4. Correct. Now these 4 feature are important. Okay. Now we feed this data to our machine learning model. Only the feature and prediction part which are important. Okay. Now in machine learning part, what we do. So I will not explain the whole thing over here, just a high level concept, because the machine learning part will complete on the next batch. So let's say, for example, in machine learning, what usually happens is like, so algorithm 1, algorithm 2, algorithm 3, algorithm n. So there are n number algorithm in machine learning part. Okay, so we try to use algorithm 1, we try to use algorithm 2, we try to use algorithm 3. Now let's say out of these 3 algorithms, Now my algorithm 2 is working best. I am getting accuracy 95%, let's say 90% accuracy I'm getting from algorithm 2. And for algorithm it's 85, or let's say algorithm 3 it's 80%. Okay, so I will choose the algorithm which is giving me a best result. So that's a part of machine learning. Okay. Okay, so that is the part of the machine learning. Before that, you can see over here, I will draw one line over here. Okay, this part is separate part 1, and this part is part number 2. Okay, so if I tell you this part 1 will take 70% of time of every data scientist. Okay, so machine learning part is just 30% only. Whenever we work on a real life project in industry, so all the data scientists spend their time 70% to 80% time on business problem understanding, data collection, data cleaning, EDA part, feature engineering, and then finally it feed into machine learning. Because the machine learning, we don't have to do anything. All the algorithms has been already built up. We just have to import the algorithm and feed the data. But this to create the good data is very much important. Okay, so there is a one concept of garbage in, garbage out. So what does this say? So basically, if our data is not good, then out means garbage out. So the result will also be same. Okay. So as much as the our feature is good, as much as our data is clean, right? So we get a good result from machine learning model, because machine learning not is not gonna do this feature engineering part, data cleaning part. No, it just work the data you are providing at this after feature engineering part, right? So garbage in, garbage out. If you give garbage to the ML model, then the ML model will give you a garbage out. Okay, so this is the concept in data science life cycle also. Okay, so garbage in, garbage out, so that we have to spend 70% of time in this data analysis part. Okay, now let's say algorithm 1 is working properly. Now I will select this algorithm 1 and try to test and evaluation. Okay, now this model will be evaluated. So testing part will be done over here. Okay, and once the testing part is completed, then we do a final visualization of all the results, and then we try to deliver our model to our client, and we can deploy in our cloud or something else, anything you can. Okay, so basically this is the life cycle. If we try to understand in very simpler way, so we can understand just like a, let's say I am cooking some food. Okay, let's say I need to I need to cook one food. Okay, now the first problem is a business problem. What food you need to cook? Let's say example, I am cooking one pizza. Okay, so for pizza, what kind of things you require? What kind of data you require? Okay, so for pizza, I need base. Okay, I need flour. I need some toppings, something data. Okay, so that is data collection part. Whatever based on the problem, based on the food. Similarly, based on the pizza, what data I need? So I need this data. Okay, now I need to clean that the data. So what are we to clean? If there is some toppings, so for example cherries or something, olives, so I need to clean all these things, right? And need to prepare for next step. And what is EDA in pizza making? So pizza making in EDA, if let's say I am a good chef or I am a reputed chef, then I try to get insights of calories. Okay, calories, fat, carbs, so all the macros. So we say macros. Okay, so all the macros I try to get insight from that pizza what I'm making, so that we can show our customer that these are the insights of food you are having right now. Okay, so that come under ADA part. Okay, we're getting insights. So again, insight, inference, analysis. Okay, remember this three word. Now after that, we do feature engineering. So it's like if you want to compare with this analogy, you can say like if I'm baking pizza and there is some other useless things. For example, let's say what we say. Let's say many people don't like some other extra toppings over the pizza. Let's say, for example, we can remove that in feature engineering, right? So based on the requirement, we can remove that feature which is not required by the customer, right? And in the machine learning part, so for example, let's say there is nobody is telling you how to cook. So what is the number of hour you have to cook for the pizza in the oven? So let's say you test with algo 1. Algo 1 is like 45 minutes. Let's say for 45 minutes you cook, but the once the pizza is cooked, you check, no, it's not cooked properly. So algorithm 1 will be discarded. So algorithm 2, let's say for algorithm 2, that is process 2, you cooked it for 60 minutes, let's say. Okay, so for 60 minutes, it's also not pretty much cooked properly. So you will discard this algo 2. For algo 3, let's say, for 65 minutes, let's say, and you check, oh, it cooked properly. Okay, so you will select the time 65 minutes. So next time you will cook that same pizza, you will select this model 3, means 65 minutes. You will basically you are training yourself of your own without any other help. Okay, so machine learning is done. Now testing part. Now you will test the pizza. Okay, so it tastes good. Now you will do some visualization, some toppings, and deliver to customer. So it's very simple. The data science life cycle, just like creating a pizza or creating any food. Requirement, collection data, cleaning, getting some insights, removing unnecessary feature or feature engineering, training, testing, visualization. Pretty much easy, right? So yeah, it got so much messy. Sorry about that, but I think it's clear for you. If there is any doubt, then just ping me in the chat. If it is clear, then please confirm.
Kiran,
So I, hmm.
could you
So
explain what model evaluation is and
mhm.
the data visualization?
Yeah, sure. Okay.
Yeah, like is it based on the best performing algorithm?
Yeah, correct. You are correct. So let's say from this machine learning model, my algorithm 2 has selected. This is the best result, 95 accuracy. Now I will check in the evaluation part with some other new data. I will try to give some data, okay, and test whether it is giving me a more accurate result or not. So just we are trying to evaluate our model, which algorithm 2 is selected. Now this algorithm, using this algorithm, I will test my model. And once the model is evaluated, everything is okay. It got approved from here, model evaluation, and we try to visualize our results. So we'll give there the visualization part. Just that this model is giving these results. It's just the visualization part, nothing else. Okay.
Okay.
Mhm. Okay. So I will just explain just this key term. So basically, many times people can get confused about the data analyst, ML engineer, and data scientist also in the job roles. So data analyst is something like this in the life cycle. So many times the data analyst part will be up to feature engineering or up to data analysis. Okay, so the data analyst will collect the data. Okay, from whether they have to collect from the, let's say, from web, or they have from database or some other resource. Okay, so they will collect the data and they will clean the data as I explained, and they will do the EDA part, featuring part. They will not come onto the ML part. Okay, so This is the work of data analyst usually in companies. And ML engineer, so the work of ML engineer comes from the machine learning part. Once they receive the data, okay, so they will do machine learning, they will do evaluation, and they will do which algorithm to select. So all the experimental R&D will be done in this part only, and this is the basic core work of ML engineer. But sometime in some companies they give for ML engineer to do whole thing over here. Okay, they will collect also data, but that's not actually a part. But in the company, sometimes they will give you some such task. But the core work of ML engineer is basically the creating the model and deploying into the cloud or something, any machine. Okay, so this is the work of ML engineer. So this is machine learning engineer. And there is one more position which is data scientist. Basically, data scientist is the something who do everything. Okay, so that's why they are on high demanding job, data scientist. So they understand the business problem, they will collect the data, they will clean the data, EDA part, feature, machine learning, everything they will do, the whole data science. So to become data scientist you need to understand whole data science life cycle and work on it. Okay, so data collection part also, you need machine learning part also. Okay, so you can say that data scientist is the summation of data analyst and ML engineer. Okay, but the minor difference between ML engineer and data scientist is that ML engineer also deploy the model or host the model. Okay, but sometimes data scientists won't do that because it's part of the DevOps, right? So DevOps is basically in development. Okay, so in software development there is a DevOps. Similarly, in data science there is ML ops. Okay, the machine learning operations we say. So that machine learning operations has a separate position also, but sometimes ML engineer usually do that. And if many company, the data scientists also do that things. Okay, but the data scientist is not so responsible to deploy the model in generally, that is done by the ML engineer. Okay, so that is the difference between data analyst, ML engineer, and data scientist. Okay, and now I will explain this pandas, numpy, matplotlib in our whole session, I mean in our whole course. Okay, so pandas is basically library. Okay, so when we try to visualize data, okay, tabular data, CSV files, Excel file, different file we try to import using pandas and try to do EDA part using pandas only. NumPy, NumPy is basically a numerical Python. The full form of NumPy is basically numerical Python. So NumPy is very fast, basically. Okay, so we have a concept of we have data structure of list in Python, right? So we have list in Python, but we have arrays. So NumPy has arrays. Okay, so that the array of NumPy is very fast than the list. Okay, I will explain in tomorrow's class. Regarding NumPy. Okay, just giving the overview only. So NumPy pandas, and there is matplotlib. So matplotlib is basically a library when we used to visualize the, like, to create some graphs. Okay, graphs, chart, bar chart, circular chart, anything, thing like that. And similarly, Seaborn and Plotly also a kind of visualization tool or library. So Plotly is very interactive. Okay, when we try to use Plotly, Seaborn. Okay, so we'll work on Plotly, Seaborn, Plotly, all these things. Okay, so for today, only this part I will cover, and I will tell you about the installation part. For first, tell me, so how many of you have Anaconda installed? Okay, installed. Install, I have. So who don't have Anaconda, can you ping me or chat? Anaconda installed, or who don't know how to use Jupyter Notebook? Okay, 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 no problem. So those who have already an Anaconda installed and they don't need installation process, okay, and they know how to use a Python Jupyter notebook, then they can leave the session, okay. So if they have any doubt, then they can ask me right now, okay. Else I will start the installation part now. So is there any doubt regarding today's class? It's a very high level concept only I have explained. Further going, we will explain each and everything very clearly, okay. Yeah, Yuvraj, same time tomorrow. So 8 to 8:10, and between 8 to 8:10 we'll start the session. We'll wait 5 to 10 minutes for all the candidates. Okay. Okay. So nobody has any doubt. So let's start with the installation part.
Okay.
Yeah, hi.
I have a small doubt. So basically, the suggestions we receive on social media or some browser, like, so is it a part of ML or the deep learning?
Recommendation you are saying about?
Recommendation or suggestions we receive, na? Right. So
Yeah, it's a part of DL.
okay, thanks. That is it.
I will explain you if you need further explanation about how it is the part of DL, or you can do research of your own. If you find the recommendation system, how to create recommendation system, there will be things. Okay, so basically we can achieve by machine learning also. Okay, but now the data is so vast, right? So so DL is more preferable. But earlier it was started by machine learning itself only. So there is particular thing. Yeah.
Okay, thanks.
So let's now start for the instruction part. So I will stop the recording.